and then I'll start the presentation and demonstration. So a quick introduction. My name is Adrian, and I'm the head of R&D at Coltraco Ultrasonics. I'm joined here with my colleague, Benjamin, who is the deputy head of R&D. We are pleased to have so many of you join us today, and we hope that this session will be a good introduction to you on how we use the Portalevel Max Plus. I'll just go on to the second slide to give you a little bit about an overview of the company. So we are headquartered in London, and we operate across a diverse market sector of about 25 different market sectors. Coltraco is our company, and where you probably know us for. We also have our laboratory, which is currently where we're at the moment with these cylinders, which is co-located with the Centre for Advanced Instrumentation, Durham University in the UK. We also have our research organisations, such as the Durham Institute of Research, Development and Invention, and we also have our Centre for Underwater Acoustic Analysis. All of these different institutions form the organisations that Coltraco Ultrasonics is part of. We are engaged in the research, design, development, manufacture, integration and sustainment of high exporting products and services. We are science-led, and we aim to bring the very best to all of our customers in the industry. So without further ado, I shall give a brief introduction to the product that you're here for today, the Portalevel Max Plus. So the Portalevel Max Plus is a new product range. It is intuitive to use, and it has a clear gas and liquid interface, as you can see in the display on the image on your screens, and also we will be doing a short live demonstration later. It has 3 calibration modes. The calibration mode I'm talking about refers to the use of the device. This is different to the calibration requirements, let's say. These different calibration modes allow you to utilize the correct setting for your cylinders. It allows greater flexibility of working across different cylinder types. It has 4 different power settings to configure it so that it's suitable for cylinders of different conditions and different sizes. It ensures the most accurate measurement possible. And lastly, it has tactile buttons, so it feels ergonomic when you're using the equipment. This Portalevel Max Plus is also UL listed, so you can trust that the equipment is designed to be fit for purpose. We at Coltraco Ultrasonics, we manufacture a range of other instruments to complement the ISO 14520 standards. The Portalevel Max Plus, which is what we are showing today, I will also be showing you the Portasteel calculation. The primary purpose is to calculate the weight of agent in all fire suppression systems to within 1% accuracy. As you probably know, ISO 14520 standards mandates the contents loss of 5% or 10%, and the Portasteel calculator calculates that for you, so you know that your cylinder is within tolerance, and if it's not, you can replace the cylinder or refill it. We also have our PermaMass Featherweight, which is our cylinder weight monitoring system, and we finally have our Portascanner AirTag 520, which quantifies leaks and locates leaks for room integrity testing to complement the door fan test that you currently already do. All right, so without further ado, I'm going to stop my presentation and move on to the live demonstration of the equipment. And my colleague here, Benjamin, will give you a brief overview of how to use the instrument. So I ask that you focus on us, the camera, and you should be able to see this. Just give me 1 second to turn the presentation off. All right, Benjamin, over to you.
Thank you, Adrian, and hello, everybody. As you can see, we've got here 2 cylinders to demonstrate for you today. We have CO2 here on my left. It's the green cylinder that you see, 45 kg agent, 100 pounds. And to the right, we have FM200, 42 kg agent inside there. The CO2 cylinder is a seamless cylinder, as you can see, whereas our FM200 is of the welded type. So I'm going to demonstrate the new Portalevel Max Plus on both of these cylinders to show you some of the different features in action and how you go about testing. First of all, I'll do it in slow time, and then we'll run through it again in actual speed. What I will do through the test is in slow time is I will move the device towards another camera which we have down the bottom, which we'll switch to once we actually start the demonstration, just to show you the screen, the display, to show you what is actually being seen on the and how you actually use it. So we'll start with the CO2 cylinder. So if we switch cameras now. Okay, so you should all now be seeing a different camera, which is a little bit closer into the cylinders, and I'll also be able to move the device closer to you through the test. So we begin, of course, by switching the unit on. So you can see, we place the sensor near the top of the cylinder to observe the readings. But before we conduct the test, of course, we need to apply a strip of gel or water to the cylinder. This acts as a couplant so that the sensor can generate ultrasound into the cylinder itself. I've got a strip of gel applied to both of these cylinders, which comes supplied with the unit, but you can't use water. So I placed the sensor on the cylinder, as you can see near the top. I'll move the device a bit closer. I'm starting to get a reading around 2,700. So as I work my way down, observing the reading on the screen, 1,900. It's now dropped. I'm on around 600. 300. Yep. So what I'm looking for on the cylinder is an area of high readings and an area of low readings. And I'm looking for the point where the readings drop from high to low. So as you see above here, we have readings of around 2,600, 700, 1,800, dropping down to around 600, 500. So I move the sensor back up into the high reading area. In this case, because the difference in the readings is quite large, what I do is I calibrate around the average high reading. So I'm not, as you can see, this isn't the highest reading that I received on the cylinder. I'm calibrating around the average high. So what happens now when I press the cal button? As you can see, the display changes and it now reads gas. Gas is the default because most cylinders, the highest readings will occur in the gas phase. So that's why it reads gas there. For this cylinder, with the different cal modes that we have, in our manual, we describe how we use each one. So for cal 1, that is typically when the difference in the readings between where you get the high readings, in this case the gas, and where you find the low readings. If that difference is quite large, with a reasonably steep drop off, and we need to calibrate in the average high area, we can use cal 2. The reason I'm using cal 2 in this case is because the highest reading I found was around 2,600, whereas it dropped to around 500. That's quite a large drop off. So we use cal 2 in this circumstance. So now, when I move the sensor down, you can still see it's reading gas. But now, as you can see, it's now reading liquid when I've passed a liquid point. So I now move back up the cylinder in small steps until I find the exact point where it switches between gas and liquid. So still in liquid. Still in liquid. And now in gas. So move down just a fine step, just to find the exact point. Okay, about here. This is the exact point where it's switching between gas and liquid. So from here, what we'll do is we measure where we found the liquid level, include the temperature that we found it, place it into our Portasteel calculator to convert that liquid level into agent mass. So we'll do that now. I'm going to switch over to Adrian, he will start describing the Portasteel calculator while I measure the height of the sensor and also the temperature.
So as Benjamin was doing the test for the Portalevel Max Plus, this is our Portasteel calculator. The Portasteel calculator functions to convert the liquid level height found using the Portalevel Max Plus into agent weight. The reason why we want to do this is because most fire cylinder only note the agent weight on the cylinder. They don't actually contain any information relating the liquid level. Filling stations and cylinder manufacturers do not usually include what the actual liquid level of the cylinder should be. They only include what the agent weight. Hence why we developed the Portasteel calculator to enable traceability. As you can see here, I've already created and saved two types of cylinders in the database. These are two cylinders which are present here in this room. The cylinder that Benjamin has just tested is the 45 kg or 100 pound CO2 cylinder. I'm going to go into that cylinder which I've saved, and I'm going to show you the details on the cylinder. I can show it to you by pressing this button. As you can see, it's the height, the upper dome height, the circumference, the temperature, and wall thickness has all been saved and recorded, including the name, the type of the cylinder, and the units. Now, when Benjamin has measured the liquid level height found using the Portalevel Max Plus and the temperature, this device will provide a corresponding agent mass. So Benjamin, what is the liquid level height?
It was 99 centimeters. I always double check, Adrian. 99 centimeters.
So the liquid level is 99, and the temperature?
11 degrees.
The temperature is 11 degrees. So as you can see, with the liquid level height of 99 and a temperature of 11 degrees, the agent weight is 45.3 kilograms. So I will press add record details, and I can include the serial number of the cylinder. Let's say the serial number of the cylinder is 003. You can then put in the printed field mass. The printed field mass is the weight that is already printed on the cylinder. So if this is 45 kg, I will put 45 kg and I'll press save record. This will bring that record down to the database below. The serial number that I've just entered, you will see is 003. Today is the 30th of March. And the liquid level found was 99 centimeters and it's converted to 45 kg. And the percentage difference is 0.71%. So this is within the 5% or 10% tolerance as required by the regulations. So this device allows your servicing technicians to inspect a fire suppression cylinder, to save the result in weight, and also enables you to export it based on these Portasteel tablet. The record comes with a date and time stamp, so you know exactly when the test has been done and you can export it. These date and time stamp are unchangeable, so you know that when you've done the measurement, it's actually there at that time. It allows for better traceability of your test processes. So this is the Portasteel tablet. And Benjamin, I think we'll move on to the next cylinder. Thank you.
Thank you, Adrian. I'll move on to the next cylinder, but just before I do, I just wanted to quickly recap our 3 calibration modes that are available. So as we've seen on this test here, when I placed the sensor on, we had readings of around 2,600, 2,700, dropped down to around 1,900 again in the gas section. Before we reached a point where the values dropped quite a steep and large drop to around 350, 500, etc. down in the liquid section. So because that difference is quite large, a big steep drop off, we used Cal2. So Cal1 is the default on this, which is again in a similar situation where you've got quite a large drop off. However, I wanted to explain that with Cal2, the difference is when the drop off is much larger. Cal3 is used when for challenging cylinders which have been perhaps rusty or a little bit older, and also cylinders where the difference between the sort of high readings and the low readings isn't very large. That's where we use Cal3. So just wanted to quickly recap on that before we move to the FM200 cylinder. And I'm just going to reposition the camera so that we can see this one a bit better. Apologies for the camera wobbling while I get this. Yep, thank you, Adrian. So we'll continue the test with FM200. Similar as before, I'll move the unit into view so that you can see what's happening on screen, and I'll describe what I'm doing. So place the sensor on the cylinder near the top. See readings of around 200, 400, fluctuating between 350 and 450. Down again, and I'm getting similar readings through 250, 350, still quite low. Now I move down again, and I'm getting 1,900s, 2,000. And again, about 1,900s, 2,000s. So in this case, the higher readings are in the lower part of the cylinder. We always calibrate in the where we find the highest readings on the cylinder. So I place the sensor in the region of where I get high readings and press Cal again. In this case, because the high readings were found in the lower part of the cylinder in the liquid section, we press and hold Cal, and the unit switches to liquid. This is you telling the unit that you have found the high readings in the liquid section of the cylinder. So the procedure is the same. Now that I've pressed Cal, I'm using Cal 1 in this case. I will then move the sensor up in steps until that changes to gas, and I'll show you when it does. So still on liquid. Now showing gas. So I'm going to move down in very small steps till I get the exact point that it changes. This part here, as you can see, it's fluctuating. You can see the bar graph is oscillating slightly. That's a good indicator that you're right on the liquid level. That's the liquid level itself, perhaps oscillating very, very, very slightly past the center of the sensor, which means it's very likely exactly on where it is. So what I'll do now is lift it slightly until it's there. You see it's just changed over to gas, exactly there. You see the oscillation again. What we'll do is we'll do the same as we did with CO2. We'll measure the height. Adrian will show you the Portasteel calculator again. We'll measure the height and the temperature, and then we'll convert it to agent mass once more.
All right, so as you can see, Benjamin has now found the liquid level on the FM200 cylinder. Again, similar to the 45 kg CO2 cylinder, I have created an FM200 cylinder here. This is a 42 kg Kiddie FM200 cylinder. I will go into the cylinder now, and I will show you what the cylinder information is. So it's about 51.7 liters. It's about 59 centimeters in height, 14 centimeters upper dome circumference, 102, lower seam height 16.5, wall thickness 3.6. So I have done all the measurements already. Just click done. And similar to the CO2 cylinder, all you have to do is just input the liquid level height and the temperature, and it will calculate the corresponding agent weight for you. Okay, Benjamin, what is the liquid level height?
It's 42 centimeters.
So the liquid level height measured is 42 centimeters. Okay, and can you measure the temperature, please?
Yes, it's sitting around 11.2.
11.2. Let's get this 0.2. So the cylinder, this is a 42 kg FM200 cylinder. I'm going to go add record details. Similar to the CO2 cylinder, I can put in the serial number. I'm just going to put in a random number for now, 123. The weight of agent printed on the cylinder is 42. We're going to go save record, and as you can see, it would be added to the database at the bottom. And the ones that we just did today is the 30th of March. 42 centimeters is 42.1 kilograms. It's got a difference of 0.34% compared to what's currently written on the label. So this, similar to the CO2 cylinder, this allows you to trace your liquid level height measurement, convert them into agent weight, and then you can compare it with the values on the label itself. This is far more effective compared to the just using the liquid level alone. So we definitely recommend that you consider purchasing the Portasteel calculator together with the Portalevel Max Plus if you think it is suitable for your job. So thank you very much, and this marks the end of our demonstration. And now we will be very happy to take any questions that anyone has regarding this. Right.
Okay, good morning. Good morning, and Benjamin. This is Vikesh from Navicom. Can you hear?
Yes, we can hear you clearly, Vikesh.
Okay, so I have got a quick question. As what we seen in the demonstration, you need to do a calibration in the higher reading, in the zone of the high reading where it is showing high reading. So it is just I just want to know technically why was there a difference between CO2 and FM200, where the high reading was shifting from the gas to the liquid region. In the CO2, the high reading was showing in the gas form in the higher region, and while in FM200 it was showing in the liquid region. Why is it that so? Is it dependent on the gas?
Yeah, so thank you, and it's a good question. Yes, so the difference that we see is due to the sound speed of which ultrasound will travel through that particular agent and cylinder. So it does depend on the agent, and it also depends on the cylinder, but more so on the agent itself. The speed at which ultrasound travels through CO2 is different to what it travels through FM200, as it is different through water, as it is through air, through any other substance. And it's that difference which is how we can tell where the liquid level is. It's how we're doing this. So the reason why it can sometimes be opposite is simply because in the gas section of CO2, the unit is receiving more ultrasound signal back than it is in the gas section. That's because it's traveling slower in the gas section than it is above in the CO2 cylinder. Whereas in the FM200 cylinder, it was the reverse effect. The ultrasound is able to travel faster through FM200 than it is in the gas section of that cylinder. It doesn't matter. The test is exactly the same, whether you find the high readings in the lower portion or in the upper portion. It makes no difference at all. As you've seen, if you do find the high readings in the lower section, as I did in the FM200 cylinder, you simply press and hold on the cal button after you've engaged it to then switch it to liquid and then move up to the liquid level. If the high readings are in the upper section, like it was in the CO2 cylinder, when we calibrate it up here, the default is gas, which is what you see immediately. In this case, we move after engaging cal, we move down to the liquid level. So that's the only difference. It's the test is the same, you just move in opposite directions.
But you need not do the gas selection onto the instrument as such. You don't do any gas. You don't do the selection of the gas on your instrument as such.
So the gas is default because in most cases you'll find high readings in the upper portion. That is our default, because most cylinders you come across, that will be the case. So when you first press cal, the device will assume you're in the gas section because that is the norm. However, if that is not what you see, you simply press and hold, it switches to the liquid. You're telling the unit that I'm actually in the liquid section. So
no, my question was, you don't need to select the type of gas, type of the the agent into your main system.
Sorry, no, Vikesh. Sorry, I missed that point. No, you don't need to select which gas. It doesn't matter. This works on most fire suppression cylinder liquid, as long as they're in liquid state, as well as other liquid types as well. This has been used in food processing on large cylinders containing things that aren't fire suppression agents. As long as it's a liquid, it's fine to use. The calibration that you see me go through, the process of pressing cal in the high reading area, is calibrating it to that specific cylinder, not just not specifically CO2 or not specifically FM200. So it doesn't matter. You don't have to select which agent.
Another question what we are facing in the Indian region is because of the ambient temperatures. See, like most of our customers, the ambient temperature in India is somewhere around more than 35 degrees most of the year round.
Yes.
In that case, we face a problem when customers are testing the CO2, gas, which I think it's the limitation is 32 degrees or something.
Yes, that's correct. Like,
Let me
do you want to take this figure?
Yeah, so Vikesh, you are absolutely correct. Customers in India or in a lot of Asian countries and even the Middle East do face an issue with testing CO2 at hot temperature weather conditions, typically above 30 degrees. The properties of CO2 turns from liquid to gas. So there's no longer a liquid level. The entire cylinder changes to gas. There are only two ways around this. The first way is you have to cool the cylinder down, whether you use water or air conditioning units or anything like that. The cylinder cannot be over 30 degrees because over 30 degrees, the entire cylinder will be in the gas phase. There is no longer the liquid level. The second thing you can do is wait until the evening, nighttime, or early morning when the temperature is lower than 30 degrees. When temperature is lower, you will be able to test. Now, the Portasteel calculator has a feature to prevent you from testing if the temperature is above 30 degrees. This will allow your technicians, your operators to make sure that whenever they input a measurement, they do it correctly at the correct temperature. Now, I'm going to show you what I mean. For example, I'm just going to move this tablet towards the camera. Okay, I have the 45 kg CO2 cylinder saved here. For example, if I test my CO2 cylinder and I found the liquid level to be at 100 centimeter, and then I measure the temperature and I realize that the temperature is 31 degrees, for example, or let's say 32 degrees, you will see that there is an error saying must be between 20 and 30. It doesn't allow you to add the record. It doesn't allow you to save the measurement. Whereas if the temperature is lower, let's say at 25 degrees, it will allow you to add the record, as you can see here. So the Portasteel prevents your users from making the wrong decision, because if the temperature is above 30 degrees, even though the user might think they found the liquid level, it's actually a wrong level, and the Portasteel will prevent that sort of error. But apart from the Portasteel, you have to cool the cylinder down, because they're above 30 degrees, the CO2 turns into gas, and there is nothing we can do about that, because that's the physical property of the CO2.
Yeah, I think that answers my question, I think.
Right.
Thank you, Benjamin.
Thank you very much, Vikesh. My colleague Lasse will be coordinating the questions asked in the chat, as well as people raising their hands. So I'll leave it to my colleague Lasse to read out the questions to myself and Benjamin, so we can cover these questions more effectively. Lasse, over to you.
Thank you very much for that, Adrian, and thank you very much for the presentation. So I just saw one other hand up there that's now disappeared. If you'd like to put your question in the chat, and then I'll read that out for Benjamin and Adrian, or if you'd like to raise your hand and then I can unmute you. I think it was from Safe Kuwait. Here we are. Please go ahead with your question.
Yes, Mr. Benjamin and Adrian. Good day. How are you?
Very well, thank you.
Is it? Am I audible to you?
Yes, we can hear you. Yes, we
Yes.
can hear you perfectly. Please
Yeah.
ask your question.
Now, my question is, we are doing the calibration 1 and 2 times, right? Now, in the part of a Coltraco level, and a normal instrument, it is also we are doing the same process. There is no change in these two instruments. The change itself, the display shows liquid or gas. Is it? That's the basic difference, right?
So there's two major differences. One difference that you identified there is the unit will now tell you if you're in the gas or the liquid section after you calibrate the unit to that particular cylinder. But also we have, as you noted on the previous units, you also engage cal to a specific cylinder in the area you find the high readings. In this case, we now have 3 cal modes. These cal modes have, through extensive data collection and testing for a large variety of cylinders, we've managed to adjust our calibration algorithms, and we've found that these additional calibration modes will give a greater usability and greater flexibility when testing on a larger range of cylinders. So what we've done is we've optimized the units in each cal level. So there's 3 in the Portalevel Max Plus as opposed to the just single cal level in the Portalevel Max previous model. This now allows you to give you more flexibility when tested. So for cal 1, that's used when the difference between the readings above and below, or the difference between the high and low readings, is quite significant. There is a reasonably big drop off. Cal 2 is used when in the same circumstance, but the difference you see is much larger, and talking 2,500 to 3,000, it drops to 350. It's a huge difference. Cal 2 is used in that circumstance, and Cal 3 is used on cylinders which are perhaps in worse condition, perhaps a bit rusty, or there's other conditions which prevents that clear indication, where you don't quite get a big drop off between high and low readings. What you might get is quite similar readings, or quite a low drop off. So it could be 2,500, 2,400s here, and then 1,900, 2,000 down here, or 1,800, etc. It's not a big drop off between the high and low. So in that circumstance, all of our procedures are in the manual to follow. It's very easy to follow, but Cal 3 is what's used in that circumstance. You would normally calibrate at the highest value in that situation. But all of this is explained in our user manual and all of our training material as well. So we've got the addition of 3 calibration modes, and the user interface will now display if it's in the liquid or gas section, rather than relying solely on the bar graph or the values.
Yeah. Thank you, Benjamin. And another quick question: is it any applicable for ATEX? ATEX approved this instrument?
Adrian,
Yeah, for ATEX approved and EX rated, so hazardous zone environments, we have our Portalevel intrinsically safe. It's a different model to the Max Plus, but the Portalevel intrinsically safe is ATEX approved. It's approved to Zone 1 environments. You will be able to see details of that on our website, and I'm sure one of my sales colleagues present here today will take your details and will forward you the information for the ATEX approved level indicator. The process of using the ATEX approved level indicator is similar to this, but at the moment that doesn't have the gas liquid indication. It will just tell you based on the bar graph whether you're in the gas or liquid, but it has the different calibration modes, quite similar to the Portalevel Max Plus. So you would find the functionality of the Portalevel intrinsically safe for the ATEX Zone 1 hazardous environments, quite similar to the Portalevel Max Plus.
Oh, thank you, Andrew. And I'm in touch with your colleague Leha regarding this ATEX approved instrument.
Yes.
If I need any more information on this, I will communicate Leha. Thank you so much. Thanks for your demonstration.
Thank you very much. We still have more time to take a few more questions for anyone that wants to ask questions.
Absolutely. So I think, Adrian and Benjamin, that the next question that we have is from Solas Marine, and that is, are densities for liquids available in the Portasteel calculator?
The densities of the liquids are automatically input in the Portasteel calculator, so they are done in the background. You will not see what the densities are, but the Portasteel calculator will do the calculation for you. So in a way, my answer to your question is yes, it is available in the Portasteel calculator, but you won't be able to see it. So all you have to do is just put in the dimensions of your cylinder, and this will calculate based on your dimensions of the cylinder, which gives you the volume. It will take your temperature, which calculates the density, and will give you the mass, which is the weight of the agent. So it will do the calculations for you, and you do not have to worry about that.
Brilliant. Thank you very much, Adrian. And then the next question from Hassan Khan. So the range of measurements of temperature for calculating the liquid level in the CO2 cylinder as shown during the demonstration was 20 to 30 degrees. So do we need to maintain that temperature only for the measurement?
Yes, the answer is no, you do not need to at all. So the reason, well, during this demonstration, between 20 to 30 degrees well, this room at the moment, I think is about sort of 15, 16 degrees. So I think what you're referring to is in the Portasteel, when I showed the temperature range, it's actually minus 20 to 30, but the minus sign on 20 was probably not clear on the camera, but it's actually minus 20 to 30. That is the entire operating range where CO2 will exist as a liquid. So there is no need to maintain temperature at all when you measure CO2 cylinders. As long as it's below 30 degrees, the Portalevel should be able to measure successfully. Now, let me explain to you why temperature is so important for CO2. For example, if this room is 20 degrees today, you find the liquid level here. If I test tomorrow and this room is hot, warmer, instead of 20 degrees, it's 25 degrees, you find the liquid level here. Now, you might actually think, oh, hang on, the agent level has actually changed, the weight has changed or something like that. Or if you find it at 25 degrees here, and then the next day at 20 degrees is here, you might think, oh, hang on, this is a few centimeters drop. It means that the cylinder has leaked. But this is not the case. The Portasteel calculator will tell you that this level or this level, due to the 5-degree temperature difference, the agent weight is exactly the same. So it's very important that you utilize the Portasteel calculator, which takes into account temperature variation, because CO2, as some of you might already know, is very, very dependable on temperature. From this 45 kg or 100 pound CO2 cylinder, I've done some measurements before, and every 1 degree Celsius change in temperature is around 1.5 centimeter of liquid level change. So 5 degrees is about 7.5 centimeters change. So you're likely to see a fluctuation in temperature of on liquid level of about this much for about 5 degrees. So if you are not converting or taking into account the temperature, you might think, oh, at warmer temperatures, the level is here, colder temperatures, the level is here. Oh, hang on, the cylinder has leaked. But actually, if you look at the temperature and you calculate it, it's actually the exact same weight, which is why we recommend the Portasteel calculator for complete traceability of your liquid level to agent weight results. As far as we know, there are currently no competitors in the market offering this liquid level to agent weight calculation. And Coltraco, we have spent many, many years developing our algorithms so that it is accurate for your application. So you can be assured that for temperature fluctuations, we've got it covered with our Portasteel calculator, and you do not have to worry about keeping the cylinder at the same temperature for testing, because with the Portasteel calculator, you can actually take into account that type of fluctuations.
Thank you very much, Adrian. And so the next question that we have is, say that one has 3 CO2 cylinders. Do we need to calibrate the device for each cylinder with the same agent type?
Yes, so the calibration, as you can see, is quite a quick process. It's an individual cylinder process, so every time you test and go down, you should be doing that, because the values may differ from cylinder to cylinder, despite it being the same agent. And that could be for a multitude of reasons, the cylinder condition, for example, or the position of the sensor on that. So the calibration feature is designed to be quite quick, so that it can be done on each individual cylinder. And as I say, once you go down in steps very quickly, identify the high region, press cal in that region, move down again until you find that liquid level. It's a very quick process, and it can be done on each individual cylinder. So to answer your question is yes, you need to calibrate for each individual.
Brilliant. Thank you very much, Benjamin. And the next question is, so most fire suppression cylinders have an option for liquid indication, perhaps through tape. What are the advantages for measuring using an ultrasonic instrument such as the Portalevel Max Plus?
It's the difference between invasive and non-invasive.
Yeah.
So it's a good question. It's more the method that you've just mentioned, as well as some others, consist of invasive technology. It's anything which is attached or invasive in these cylinders is a weak point, essentially. Just like the valves are usually the source of leak, and that's because it's the point in which your two pieces are fixed together. If you imagine an invasive liquid level indicator is just another thing that is attached, which could fail. So we prefer non-invasive technology for that reason, because there's less chance your cylinders will leak, and also we find it safer to use, and generally can be more accurate. So
And I would add as well that though some cylinders already have the built-in level indicator, these are usually the magnetic dip tape that we use. Quite a lot of cylinders, particularly the higher pressurized systems, because they are either in seamless cylinders or due to their design, they don't always have the built-in liquid level indicators. In that situation, the Portalevel Max Plus is the most suitable unit. And even if your cylinder already has a magnetic dip level indicator, the accuracy may be slightly different to the ultrasonic measurement method because of how you pull the magnetic dip tape out, and it depends on how you feel. You have to feel the pull of the float as it reaches the level, and then you make the measurement. So these are quite subjective. We believe the ultrasonic technology, when developed and used correctly, can be more accurate than these magnetic dip tube level indicators. So we believe there is merit and there is a benefit of using an ultrasonic liquid level indicator. You will obviously test cylinders which already have the liquid level indicators inside. Also, I'm sure due to your range of testing needs, you will also test cylinders which do not have the liquid level indicators inside, such as CO2 cylinders or other highly pressurized fire clean agent systems, which are stored in seamless cylinders, for example.
Fantastic, Adrian, Benjamin. Thank you very much. So the next question is the Portasteel calculator an app, or is it a separate device to the Portalevel Max Plus that one needs to purchase additionally?
The Portasteel calculator, we supplied it on an ergonomic, robust, ruggedized tablet to withstand any environments that you are working in. It's rated to IP68 and it's got a really strong rubberized case, so if you drop it, it will be fine. At the moment, we sell it separately with the Portalevel Max Plus. We do a package deal where if you buy the Portalevel Max Plus, you will get a discount for the Portasteel. So I strongly encourage that you buy these as a package. And we will be able to offer you a package deal for them. It's very, very useful for testing your cylinders. Like I said, it allows for traceability. Once you find your liquid level, there is no indication on the cylinder where the exact liquid level should be from your manufacturer or from your filling station. All you get most of the time on the cylinder is the label that says field weight, pair weight, and gross weight. The field weight is what we need, and the Portasteel calculator will convert the level height from your Portalevel onto the agent weight or field weight, and you can compare it with the label and the field weight. You do not need to worry about where the level is. As long as the measurement, the calculation matches with the field weight, it means that your cylinder is full. And it also does the calculation for you where it calculates your measured field weight and the actual field weight printed on your cylinder, and it gives you the percentage difference. So whether you are using NFPA regulations such as NFPA 25 or NFPA 2001, or you're using ISO regulations such as ISO 14520 or ISO 6183, there is usually a requirement for 5% agent loss for liquefied clean agent systems. So that is NOVEC 1230 or FM200. The permitted agent loss is 5%. So the Portasteel calculator will calculate what the agent loss is based on your measurement. If it's more than 5%, it will be red in color to say that it's over the permitted value. And for CO2 cylinders, NFPA 25 and ISO 6183 says that it's permitted for 10% agent loss. Again, the Portasteel calculator will make those calculations for you. And again, it comes with a date and time stamp, so you know when your engineers and technicians are going to do the servicing. You can export a report on the USB directly to a computer or a USB stick to complement your servicing. So it is a very useful tool to be used together with the Portalevel Max Plus. And like I said, if you purchase it together, the Portasteel, when purchased together with the Max Plus, there is usually a package deal that our sales team will be able to offer you.
Brilliant. Thank you very much, Adrian. And could the Portalevel Max Plus be used on chlorine cylinders, for instance?
We believe that any cylinders containing liquid, so whether it's chlorine or any type of liquid, should be testable using the Portalevel Max Plus. The Portalevel Max Plus has the gas and liquid interface, as my colleague Benjamin demonstrated and explained earlier. All you have to do in any cylinder that you test, I will do a quick recap. In any cylinder you test, you scan from the top to the bottom or about a third down the base from the cylinder, and you recognize where in your cylinder you get your high reading. On the CO2 cylinder, your high reading is in the upper section. So you place the sensor onto the upper section and you press cal. Once you press cal, the first button would say gas. And for a CO2 cylinder or any cylinders where you find your high reading in the upper section, gas is correct. Then keep moving your sensor down in steps. When you hit the liquid level, the display will change from gas to liquid. So you know that you've reached the liquid. You can go 1 or 2 steps down to confirm that that's the liquid. It should still stay liquid, and then you can move back up. The exact position where it changed from gas to liquid is your liquid level. So whether it's chlorine cylinders or any cylinders, the process is the same. As we did with this FM200 cylinder, we started from the top. And we found that the high readings is not at the upper section, it's actually at the lower section. That is absolutely fine. You just place the sensor again back to the position where you found your high readings. In this FM200, it's the lower section, which is in the liquid. You press and hold the cal button and it will change from gas to liquid. And then you know that you're in the liquid phase where you engage calibrate. You move your sensor up slightly until you get gas. And then you can go up 1 or 2 steps, gas, and then you go back down until you find the exact point where it changes from gas to liquid. That is your liquid level. So same procedure, do your full scan, find your high reading, engage cal at your high reading position. And depending on whether you're in the gas or liquid, you press and hold, or you just press once, and it will be a far easier and seamless process when it says gas and liquid.
Brilliant, thank you very much. And so we're coming towards the end of the webinar now, so we've only got time for 2 more questions. If you do have any more questions, please put them in the chat, and one of our experts will get back to you as soon as possible with the answer. So for the second last question, do you need to calibrate the Portalevel Max perhaps every 6 months, yearly, or is that not required at all?
Yes, so for calibration requirements, we believe our instruments will be fine for 5 years without any calibrations. Many standards such as UCAS, UNIDO, NICS, all of these global standards for calibration usually recommend annual calibrations. And for that purpose, we also recommend annual calibration for our equipment. During the annual calibration, we look and inspect your equipment, we service it, we make sure that this performance is similar to the master standards, master unit standards, so you can be assured that your equipment is functioning correctly. So we recommend annual calibration in line with the global standards, which we follow. But at the end of the day, the frequency of calibration is at your discretion. So it's at the customer's choice whether you want to calibrate it frequently or not. It is up to you, because we believe some customers follow a different standard, may require calibration more frequently. Some may not really need calibration. So it is up to your discretion. And I think we have a few raised hands, Lasse. Might we be able to direct the questions to those raised hands instead?
Absolutely, that sounds very, very good. So, so I think it was Mohammed Hoda first. So if you'd like to unmute yourself and ask your question, please.
I want to know, I have a Mac Plus.
So you're very quiet. It's very difficult for us to hear.
Is it clear now?
Yeah, it's much better now.
All right. I hope you're doing well.
So I think it was clearer when you sat back, because I think when you're close to the screen, we couldn't really hear. Yeah, this is better. Yeah, can you ask the question again?
So I have a Max, a portable Max, which is unused in the box. Last month. I want to upgrade it. All right. Do I need to go for the hardware here?
So there are a few options to upgrade your Portalevel Max to the Max Plus. We offer two 2 or 3 different options depending on when you buy your Portalevel Max and things like that. So the first option is a software upgrade, which basically means that you send in your Portalevel Max and we will change the software in your Portalevel Max so that it matches to the one on the Max Plus. There is no hardware modifications that we will do to your unit. We will only upgrade the software. The second option is you trade in the unit. So you give us your old unit. We will give you a discount, a trade-in value for your old unit and give you a brand new Portalevel Max Plus. So we have both options. If you like, I will make sure that one of the members of our sales team note your details in this call and they will send you the offer and the various different details associated with it.
No, I'm already in touch with Miss Karen.
Okay.
So our point of view, first thing, and can I measure LPG, the content of LPG mass?
I think there was going to use an LPG. Am I correct? Did you ask if you can use this on LPG?
Yeah.
Yes, like this is similar to what Adrian described before with monitoring other liquids, other than what you've seen here. Again, if that whichever agent you're looking at is in liquid form, you can follow the same procedure and find the liquid level.
Yeah, it's more dependent on the cylinder size and the shape and things like that. So LPG, if it's stored in similar cylinders like this, that should be able to be tested with no problem. So get in touch with us if you have a different size and you have any concerns, and we will help you address it.
Brilliant. And then
the Portasteel calculator won't be able to detect the LPG, right?
No, at the moment, because there is not really a demand for LPG weight measurement, so we don't have LPG in it. At the moment, it's only popular fire suppression agents like your CO2, FM200 or HFC 227, NOVEC 1230 or FK 5112. We have FE25 or HFC 225. We have FE13. We have Halons as well. But LPG, we don't have at the moment, unfortunately.
And last but not the least, I want to ask, is it applicable to, clean agents, not clean agents, but we call it the inert gas system, which remains, no? Is working on it in future, we might get something to, to measure the agent mass in.
We have,
as we say, yeah.
At the moment, we don't have a device that's suitable for testing non-liquefied agents. So at the moment, the Portalevel Max Plus shown today's demonstration is only for liquids. We have 2 different solutions. One which is already in the market, another one which we are looking to launch. Benjamin, might you be able to explain a little bit about these 2 solutions for inert gas systems? Just quickly.
Yes, I mean, very quickly, we've got the perma mass featherweight, which is due to be available very shortly. This device is a continuous monitoring unit. It connects to a bank or row of inogen systems, as well as other systems as well, such as CO2 and NOVEC, but it's very suitable for inogen systems, IG541, for example. So it's this will continuously monitor the weight of these cylinders, and if there's any change in weight, the unit will alert you. And it's accurate to 100 grams. So if there's a 100-gram change in your cylinders, the unit will notify you that that cylinder is leaking. It'll tell you by how much. And also for inogen systems, it won't only tell you how much agent has leaked. It will also tell you the pressure change, which is related to that mass difference. So it will tell you the change in mass, the percentage loss of mass, the change in pressure, and the percentage loss of pressure as well for inogen systems. And it's a continuous monitoring system. It can be configured to meet your regulatory standards. That's your cylinder needing replaced if it's either 5% or 10%, whichever cylinders you're monitoring. And once it's reached that point, the system can be configured and connected to your fire suppression, so your fire panels, so that you can alert the facility that one of the cylinders has leaked past its critical point or past its threshold. So it's a continuous monitoring unit.
So basically, we have a few other type of solutions, not particularly the same as the Portalevel, but a few different types. As the one that Benjamin has just mentioned is a fixed system where you hang your cylinder. It converts the pressure into weight, so you can monitor the contents through that. Again, we will be happy to send you more details if you're looking for instruments for monitoring and measuring non-liquefied gases such as inert gases. We have a solution for that as well. All right. Well, thank you very much. And I think there is one last raised hand, lastly, and then I think we'll probably have to call this to a close. Don't worry for those of you who have not have your questions answered. My colleagues present in this call will record your details and your questions. And after the webinar, we will send you the answers to your questions, and you're free to contact us at any time to ask further questions as well.
Brilliant. So please go ahead, Mr. Sabzi. I believe it's you with the raised hand there.
Hello. Hello, everybody. Thank you very much for your valuable demonstration. I have two questions. I try to ask you briefly. First, is this instrument can be applied to measure the level of lubricating oils in lubricating oil tanks? Is it possible? And if yes, how about air bubbles in above of liquid level of lubricating oil in the tank? And the second is, do you have any plan to equip this valuable instrument to automatic distance calculation, for example, by adding a laser distance meter sensor to it in the future, of course? Thank you very much.
Do you want to take first? I'll take this first. Okay. Right. So thank you very much for your question. So the lubricating oil tanks, we actually have two solutions for it. One solution could be the Portalevel Max Plus, as you see in this demonstration. If the lubricating oil tanks is similar shape and size to these cylinders, then I'm sure that this Portalevel Max Plus will do the job. We also have a different product called the Porta Tank. If you've probably seen it in our marketing materials, the Porta Tank is designed for testing liquid levels of any tanks, regardless of shape, size. It tests from 0.5 meter to about 15 meters wide. It can be a rectangular shape. It can be any shape at all. The Porta Tank will find the liquid levels in those tanks. So for lubricating oil tanks, whether it's in a square tank or a bullet-shaped tank, the Porta Tank actually is a more suitable instrument for that. And I believe, yeah, that will I would recommend that for your application for lubricating oils, actually. And for the second question about the distance measurement laser pointer, we actually, in the past, we used to supply as an additional accessory. It's a portable laser pointer that you use with the equipment. So it's not together with the equipment. It's a portable instrument that you can take and just measure. It's like a range finder. You just press it and it measures the distance. So we do supply that in the past as an accessory. If you need anything like that, we can supply it together when you purchase the instrument with no problems at all. So it should be fine.
Okay, thank you very much.
Thank you. So yeah, I guess that sort of concludes the session today. We are running another session this afternoon at 3 o'clock UK time. So if you are free, or if it's more suitable for your time zone, please feel free to join us at 3 o'clock UK time this afternoon. We will do the same demonstration again, and then we will have the same format with the Q&As afterwards. So we will be around as well to answer your questions. And in the meantime, if you have further questions, please drop us an email, give us a call. We are here to help you, and we want to hear your thoughts and your feedback on our demonstration and our equipment as well. And we ultimately want to, if you have a problem, we want to help you resolve it. And thank you so much for all your time and your patience in this training, the demonstration video and webinar. And thank you so much.
Thank you, everybody.
Thank you very much.
Thank you.
Thank you.
Thank you, everyone. We will call this to a
Thank
close.
you.
Thank you.
Thank you.